Hi, and welcome to this course about writing automated unit and integration tests for JavaScript. My name is Maximilian Schwarzmüller, and I will be your instructor in this course, and I'm super happy to welcome you on board of this course. Now, in this course, we're going to start at the basics. We're going to learn what exactly automated tests are and why you might want to add them to your projects. And then, of course, you're going to learn how you do that, how you do write such unit and integration tests, and what these things actually are. You're going to learn all of that at some concrete examples, so that's not just a slides-only course. The opposite is the case. We have plenty of examples and demos, and therefore I would suggest that we don't waste any time, but instead we dive right in and we start with the most important question: what exactly is testing, and what are these unit and integration tests? So, what is testing? Well, testing is a broad term, and in the end, it always typically means that we want to verify whether something works as intended. And when writing software or building websites, which in the end is writing some software, then we typically want to test whether that software or that website we're building is working the way we expect it to work. And we can, of course, verify that. We can test a piece of software or a website by doing some manual testing. But manual testing will have a couple of downsides, and that's why we also can do some automated testing in addition to manual testing. Now, manual testing, of course, means that we, for example, visit our demo website locally on our system whilst we're building it. So we spin up some development server and we test the website whilst we're working on it. And we test the various features whilst we're working on the site. And this is very important and something you definitely want to do and not something you should avoid. But of course, it's also tedious and cumbersome. It's especially cumbersome if you don't just test the feature you're currently working on, but if you always have to test all the features and all the different ways of using a website whenever you make a tiny change. And you might want to test all these possible scenarios because, of course, maybe you changed one part of a website, and because of that change, some other part stops working. If you don't test everything, you will miss that something stopped working, and that can be a problem. But of course, if you do start testing the entire site, all its features, and everything that's involved in this site, every time you make a tiny change, then you have a lot of work to do. And that's where automated testing comes into play. With automated testing, the idea is that you write some code that tests your code. Yeah, so you're writing extra code which is executed during development or whenever you added a new feature, and this code will then run a predefined list of tests that test various aspects of your site automatically, always by following the exact same steps and flows. Therefore, when you add automated testing to your toolbox, you have some initial setup effort and you have to write the testing code initially, but thereafter you have no effort. With manual testing, it's error prone. It's easy to forget to test a certain part of the website, and it's not guaranteed that you always test everything in the same reliable way. You might test a certain feature in different ways at different point of times. If you have automated tests, if you wrote code that tests your main code, then that code will always execute in the same way and it will always perform the same test. It's therefore predictable and consistent. In addition, with manual testing, a downside is that it's of course often incomplete because you might forget to test a certain scenario or aspect. With automated tests, once you define a test, it will always be executed when you run all your tests. Therefore, it's much easier to achieve a high amount of code coverage, and it's easier to make sure that you test all kinds of different scenarios. Whenever you find out that there is a certain scenario or user behavior you want to test, you can just write a new test and add it to your project, and the next time you run all your tests, this new test will also be included. So therefore, automated testing is something you should strongly consider adding to your projects. And as mentioned, it's not a replacement for manual testing. Manual testing is important, especially when you are currently working on the project, but you should not only do manual testing. Instead, you should also add automated tests to your projects. And this course is, of course, all about automated testing. You will learn how to add such tests to your project, how to execute them, and of course, most importantly, how to write them and which kind of logic should go into your testing code. So automated testing is something you should consider adding to your projects. But there are different kinds of automated testing. And one popular kind of testing about which this course is mostly is unit testing. But what are unit tests? Well, let's start with units. What are units? In the end, units are the building blocks of your app, and ideally, these are the smallest possible building blocks. Now, what are application building blocks? Typically, functions or classes, or if you're working with a framework or a library like React or Angular, then a component could also be a building block. But it's not just about that. It's about functions in general, and typically, indeed, if we speak of a unit, we mean a function. So a unit is basically, or in most cases, a function, or also quite often a class in your overall project code. And all these units combined make up your application. So in our application, we have multiple functions and classes working together, and therefore our application is in the end made up of all these functions and classes, and therefore of all these units. So an app is a combination of all these units, and the idea behind unit testing is that we write tests for these individual units that test these units standalone, and if all units were tested, then the overall app should work. Though we typically back this up with another kind of test, integration tests, about which you'll learn as part of this course as well. And whenever we make a change to our code, we can run all our tests again, and therefore it's easy to detect whether a change in a certain part of our code, a certain part of our project, suddenly broke or changed some other units as well. If we change something in file A, and that has some indirect influence on another file or another function in another file, then with help of unit tests, if we wrote tests for all our units, and if we wrote the right tests, we will find out if we accidentally break something. In addition, even if it's not about such cross effects, even if we're working on a piece of code and we're changing something in an existing function, our existing unit tests might tell us whenever we accidentally break this function or a certain aspect of that function. And that is what unit testing is all about. It's about writing tests that test different expected behaviors of our core building blocks of our applications, typically of our functions and classes. But why would we add such unit testing? Well, if we do, and if we test all these different units, all these different building blocks that make up our application, then we can avoid endless amounts of manual testing, because again, we have all these predefined unit tests, which we can execute whenever we make some important code change. So therefore, we can easily test our entire code base by running some automated tests instead of performing a bunch of manual tests, which of course takes way longer. And it's way easier to cover our entire code base, or almost our entire code base, with unit tests, because of course we can add as many unit tests for as many units, so as many functions as we want to. And again, whenever we then change some code, we can run all the unit tests to find out if there are some effects between those different units and if we broke something. And as you will also learn throughout this course, and as you also learn in my Clean Code course, in case you also took that, adding unit tests to your project will also force you to write cleaner and better code, because testing is easier if your main code is clean and written in a good way. But I will come back to that throughout this course, of course. So that's unit testing, and that's what units are. And this course is primarily about unit testing. But unit testing is not the only kind of testing we can perform. Besides unit testing, we also have integration and end-to-end testing. And actually, there are other kinds of testing as well, for example, accessibility testing, but these three kinds of tests are the most common and popular forms of automated tests that you will encounter in most pieces of software and most websites. And as a side note, the concept of automated testing is not exclusive to JavaScript. It exists in basically all programming languages, so what you learn here will indirectly also help you with other languages in case you're interested. Now, we did learn about unit testing in the previous lecture. We learned that it's about testing the individual building blocks, functions, and classes that make up our application, and that all these building blocks are tested standalone. And the idea, as mentioned in the previous lecture, is that if our building blocks work, the entire application should work. Now, with integration testing, we build up on unit tests, and we actually also test the combination of building blocks, the combination of units. And we verified that if different units are executed together or are working together, the overall app still works as intended. Because the idea is that even if all our building blocks do work correctly individually, once we combine them, they might not work as expected anymore. And I will come back to this idea later in the course, because in this course we'll also take a look at integration testing and see how it's related to unit tests and how you can write integration tests. Now, end-to-end testing then is a different kind of testing, which is not directly related to unit or integration testing. The idea behind end-to-end testing is that you focus on specific user behaviors or specific API interfaces your application might be providing, and you test entire flows, entire application features. For example, if you're building an image upload API endpoint, you might want to test the entire image upload workflow, which includes extracting the image from the incoming request and then storing it on the file system. With unit tests, you would test the individual parts that make up the flow. With integration tests, you might test combinations of those blocks. With end-to-end tests, you would test the entire flow. So with end-to-end tests, you test the actual things real users or programs interacting with your program would do. So therefore, these are the most realistic kinds of tests, you could say, but they also bring their own challenges, and ultimately, you should combine all these kinds of tests in your projects. You should write unit tests, you should then also add some integration tests, and you typically also want to add some end-to-end tests for those important user behaviors and complete processes that take place inside of your app. You want to have unit tests because those allow you to quickly spot and pinpoint breaking changes. With unit tests, it's easy to tell which part of the application is affected by a change because you test all these parts individually. But of course, unit tests do ignore the actual user flows and interferences. Instead, you test these individual building blocks. Now, you do have some combinations with integration testing, but you still only test the combinations you want to test. Therefore, you don't model the entire user behavior flows there, but just selected combinations of units. Now, once you switch to integration testing, it of course becomes a bit harder to spot which exact part or unit of an application broke because of a change, because you're testing the combination of units. Now, with end-to-end tests, as mentioned, you do test those realistic behaviors of users and those realistic flows, those realistic processes that take part of your application. But of course, with end-to-end testing, it becomes tricky to cover all possible behaviors that can be challenging. And if things do go wrong, it of course can take some extra work to find out which exact part of the application broke and which part of the application is causing a certain test to fail. As mentioned, you typically want to add all these kinds of tests, and we have this concept of a testing pyramid where you might want to add a lot of unit tests, basically tests for all your units that make up your app, all your functions and classes, and not just one test per unit, but instead multiple tests per unit, as you will also learn in this course. Then you want to add some integration tests, and you want to have a couple of end-to-end tests for the most important behaviors and processes in your app. This, however, is no hard rule, and there definitely also are people advocating that you should have more end-to-end tests than unit tests. Ultimately, knowing all kinds of tests is a good idea, and with this course, you will learn how to write and add unit and integration tests, which are super important fundamentals you always must know when it comes to writing automated tests for your programs. Now, before we come to an end for this section here, I also briefly want to talk about another testing-related concept, which is test-driven development. Now, test-driven development is in the end a framework or a philosophy for writing tests, you could say. And the idea behind test-driven development is that you don't write your application code first and then some tests for that code, but that instead, as a first test, before you write any application code, you write failing tests where you in the end define the expected behavior. Then you implement the code that should be tested, which of course should be implemented such that the behavior is met and the test therefore succeeds. And then you can iteratively refactor and go through that flow over and over again and write a new test whenever you want to add a new behavior or a new unit, write a failing test first, then implement the logic, maybe optimize the logic thereafter, and so on. And that is one interesting way of writing your tests. This course is not about test-driven development though. This course is about learning the fundamentals of unit testing and how to write tests instead. And once you finished this course, you of course would be ready to also explore the concept of test-driven development if you want to.